Welcome to the latest edition of Under the Brown Jacket, featuring me, Jason Collier. You can follow me on Twitter at Boconuts. Hi, I wanted to take a few minutes just to run you through what a demo of Scale Computing's HC3 is all about. I talk a lot about simplicity in some of the blogs and videos that I've done, and now I want to show you just exactly what it is and how easy it is to use. So one of the things I want to show you is how easy it is to create a virtual machine in HC3. So in the virtualization tab, you'll see all the virtual machines that are running on the system. So up here at the top is effectively a heads-up display that shows where all the virtual machines are on the cluster. You can see I have, an ADS server over here, my primary, secondary, some Exchange front-end and mailbox servers, Wiki, WordPress server, all running on this cluster that we have here. And this shows kind of a memory footprint of each one of those nodes on the system. Now you'll also notice up here in the upper left-hand corner CPU, memory, and storage utilization, and also any action items that are on the cluster, and data states and redundancy. This gives you an overall view of the health of the cluster. It's going to show you, this is the CPU utilization of the entire cluster itself, memory utilization of the entire cluster, not individual nodes within the system. So when I'm creating a virtual machine, what I want you to do is pay particular attention, not necessarily to what I'm doing, but what I'm not doing. So if I go in here, click Create, and I'm going to go ahead and call your test VM here. And this is just going to be a test virtual machine. Now, operating systems, if you can virtualize it on an x86 platform, you can virtualize it pretty much on this system as well. There are certain operating systems, like we've got listed here, where we have enhanced drivers to get you even more performance and optimizations under the system itself. So I can select, I'm going to do in this particular instance a Windows 2008 Server R2. And now I can go in and basically give the virtual machine some basic constraints. How many virtual cores I want to assign to that VM. Let's say I want to put 4 virtual cores in there. How much memory, if I want this to have 4 gig of RAM associated with that particular VM. And then from a storage pool perspective, this is really, think of it more as a logical container. Not necessarily, it's going to dictate, specific placement within the cluster. This is just a logical container that you can use later down the road for things like snapshotting and replication within the cluster. Now I can go to the next one and define my effectively the size of my C drive. In this particular case, 100 gig is fine for me. I can add and remove drives from here. But I'm just going to go ahead and say leave this at 100 gig. This is also creating a thin provisioned file on the back end object store that we have. So it's not actually consuming 100 gig of space. It'll basically put that limit on it as it grows. Then I can select, where my operating system image is. I can either upload it directly from this. Once again, this is all within a web browser here, or I can choose an existing ISO that I've already got on the system. Now, by default, we create an ISO share that you can upload ISO images into the system. So I'm going to go ahead and pick my Windows Server 2008 image, click Done. And effectively, that's it. I have created this virtual machine on the cluster. So there was no. What did I not have to do? I did not have to go into. I didn't have to go into a storage subsystem. I didn't have to configure a LUN. I didn't have to. Make sure my iSCSI configuration was set up properly, my multipathing was configured the right way. I didn't have to do any of that stuff. All I had to do was basically go in and do that. Now, looking back here at the screen, if I want to start that virtual machine up, I can go ahead, click this down here, go start. And what it's going to do is by algorithm, it's going to look at, the overall utilization and load on each one of those nodes. What we do is we monitor about 1,500 different conditions, per node within the system. And one of those things we look at would be, overall load average. Now, since this is a fairly balanced cluster, this actually went ahead and started the virtual machine on the first node within the cluster. Kind of would have guessed that. But really, it's going to look at things like CPU load, memory utilization, I/O utilization on those nodes, and determine the best place on the cluster to start that virtual machine up. Now, once this is actually started up, I can actually click here and open up a console to that virtual machine. And this is actually a remote cluster that I'm running on, and this particular remote cluster is in our San Mateo office, and I'm in my garage here in Sunnyvale, California. And you can see, though, all still within the web browser, I have console access directly into this particular virtual machine. So now, of those 1,500 conditions that we monitor, there are other things that we monitor, like failure conditions. So, an example would be, say, something starts to go wrong with the system, and if it's one of those conditions we monitor that we check, we can go in there and basically start a live migration. Now, there's nothing going wrong with this particular node, but I can trigger that by going in and doing a live migration, basically doing a move of that virtual machine from one node to another. So I'm going to go ahead and give it, say, the target node of, say, the second node within the cluster. Click OK, and that is going to move my virtual machine over to the second node in the cluster. Now, you can do that manually, but that's also something that we do in the event we start to detect, deterioration in a node's, ability to function. Now, the other way in which nodes can fail would be that catastrophic failure piece, where the cord pull scenario. And in that case, what would happen is you would lose the node. The virtual machines on a node would go down, but then they would start spinning up on the remaining nodes within the cluster. And the good thing is, simplicity is really the core tenet of the product, and there's really, not a lot else to show you. There's a few other features and stuff that are in there that are useful. Example, if you wanted to, clone a virtual machine, you can do that. You can come down, create a template, sysprep it, create a clone of that. You can add drives, edit any of the parameters within there. But really, this is designed to be simple. This is designed to be something for the small to medium businesses that don't have a lot of time and resources. They don't have a SAN administrator, don't have a storage admin, don't have a virtualization expert. This is built to be something for effectively the everyman IT shop that can be easily run and operated. Oh, and one other thing. That virtual machine I did move, you can see that moved over to the second node within the cluster, and here we are still, console into this, and still all up and running. And yeah, so that's really it for us. We really wanted to create products for the mid-market that basically are simple, easy to use, and also highly reliable. Scalability, high availability, and simplicity are really the core design tenets in coming up with this product. One of those storage pools that we have is an ISO pool, and what I can do is select garbage truck. Well, looks like I'm going to be redoing the audio on that. That's lovely. Well, at least I can cancel out of that. Redo.